Today's lesson is on logarithmic functions, definition of logarithms. Well, my learning objective today is I can use laws of exponents and rational exponents to evaluate logarithmic functions by writing the logarithmic function as an exponential function and rewriting both sides of the equation in the same base to solve. All right, let's start out with some basics. The definition of a logarithm is for x greater than 0, a is greater than 0, and a is not equal to 0, y equals log of a x if and only if x equals a to the y. So the first thing I notice is x has to be greater than 0. So this is a domain restriction. Up until now, we've just talked about there were restrictions with fractions and radicals with an even index. So now I'm going to add another domain restriction that if I'm talking about logarithms, then x, whatever I'm taking the log of, has to be greater than 0. So f of x equals log base a of x is called a logarithmic function with base a. So a is written as a subscript, and that is what the base is. So base 10 that we're most familiar with, because we have a base 10 counting system, is called the common log. And base e, we've already talked about e, is called the natural log. So anytime I see log with no subscript here, that means I'm log of base 10. And if I see ln, that means I'm talking about log of base e, but we write it as a ln. Okay, properties of log. Log base a of 1 equals 0 because a to the 0 equals 1. Log of base a to the a equals 1 because a to the 1 equals a. Log of base a of a to the x equals x because the log and this kind of undo each other. So I'm just left with is x. And it doesn't matter what order I have it in. When I have both of them together, one undoes the other. Because these are the inverse property. So exponential functions and logarithmic functions are inverses of each other. So if log of base a to the x equals log of base a to the y, then I know that x equals y because my logs are 1 to 1. All right, so let's do some problems. So if I work with logs, and you probably just maybe got started with them, but now we're going to solve word problems with these. And I find the easiest way to switch back and forth between them is I always start at the base and I go counterclockwise through the answer to the exponent. I'm going to do the same thing when I'm going the other way. So I start at the base. I'm going to go counterclockwise. This time I'm going to go through the exponent to the answer. So I'm going to just write in a counterclockwise circle. All right, so let's start. So example 1, I'm going to write in this order. So to rewrite my logarithmic equation in exponential form, so my base is 4, and then I went through the 2, so to the power 2, and that equals 16. So I start at the base. The next thing, the answer is the exponent, and go through. All right, so let's try again. So I start at the base, and I'm going to go this way. So I'm going to write, so b to the 5th equals 7. All right, what is my base here? I have no base written, so it is assumed to be 10. So I'm going to write this way. So 10 to the negative 4 equals x. Okay, so when I'm working in logarithmic form, and I want to take my exponential and write it in logarithmic form, I'm kind of doing the same thing. So I'm starting at the base and going this way. So I'm going to I start by writing log. My base is, so I started at the 2 of 1/8 equals negative 3. So the order I'm going through my counterclockwise is how I'm writing from left to right. So I start at the base. So I start with the word log of 10 of 1 equals 0. Now I don't have to write the 10. Oops. How did that happen? I don't have to write the 10, but I'm just doing it just so you can see what I'm doing. Okay, so let's try the last one. So I write the word log first. My base is 5 of 12 equals a. All right. Let's simplify each logarithm. I want to set the logarithm I want to simplify equal to k. I'm going to write the equation in exponential form. I'm going to rewrite each side of the equation using the same base. I'm going to set the exponents equal and solve. Okay, so I start by setting this equal to k. And then I want to rewrite this in exponential form. So 4 to the k equals 64. So my goal is I want to rewrite to the same base. So I know that 64 is really 4 times 4 times 4. So 4 to the k equals 4 cubed. So when my bases are equal, then my exponents are equal. So I know k equals 3. Okay, let's have a try here. So this I think is easier if you rewrite this as a fraction, but we can do that first. So I'm going to first set it equal to k. Then I start at the base and I go counterclockwise around. So I say 3 to the power k equals 27 times the square root of 3. So I can rewrite this as 3 to the k equals 27 times 3 to the 1/2 power. The square root is the 1/2 power. And I also know 27 is 3 times 3 times 3. So I can rewrite this because I have 3 times 3 times 3 times 3 to the 1/2 power. So I add my exponents. So 3 to the power k. So I have 3 plus a half. So that's 3 1/2, which is 7 halves. So this is 3 to the 7 halves. So my bases are equal now at 3. So my exponents are equal. So k equals 7 halves. Right? Let's try number 9. So first step is I set equal to k. I start at the base and I go counterclockwise around. So I say 2 to the power k equals 1/8. My goal is to rewrite, so I'm in the same base. And I know 8 is 2 times 2 times 2. So 2 to the power k equals 1 over 2 cubed. So my bases both need to be in the numerator or in the denominator. So I'm going to bring the denominator up to the numerator. When I do that, I need to change the sign of the exponent. Oops, I'm sorry about that. So this is going to be 2 to the k equals 2 to the negative 3. So now my bases are equal. So my exponents are equal. So I get k equals negative 3. So if so big picture here is if my bases are equal, then my exponents are equal. Okay, important concept. All right, so let's solve an equation this time. Oops. So I don't have to set it equal to k because I am actually equal to something. So I'm going to rewrite this as an exponential equation. So 5 to the power 4 equals x. So 5 to the 4th is really 5 times 5 times 5 times 5. So 5 times 5 is 25 times 25 is 625. Okay, let's try number 11. Again, I have an equal sign, so I don't have to set it equal to k, but I'm going to use the same process. So I start at the base, do a counterclockwise loop around. So rewriting exponentially, the base is x to the 5th power equals 32. So I'm going to rewrite 32 to something to the 5th power because I either want the exponents equal or the bases equal. So since the variable is the base, I want to set the exponents equal. So I know 32 is 2 to the 5th. So this is x to the 5th equals 2 to the 5th. So when the exponents are equal, then my bases are equal. So x equals 2. So just like if my bases are equal, my exponents are equal. The same is true going the reverse way. So if my exponents are equal, then my bases are equal. So I'm trying to get either the bases equal or the exponents equal, whatever is not the variable. Okay, so let's move over to some properties of logs. Right, we have two different forms, a condensed form, an expanded form. So we have four properties. So the product property, when I'm multiplying m times n, this is going to be the log of b of m plus log of b of n. So when I'm multiplying here, I'm adding in the expanded form. For the quotient property, when I'm dividing here, then I'm subtracting. So this would become log b of m minus log b of n. So the power property means I bring the exponent to the front. So this becomes k times the log of base b of m. And sometimes I have to change my base. So the change of base formula is the log of base 10 of a divided by the log of base 10 divided by b. So when I'm talking about the base of b of a, so I want to use base 10 because that's on my calculator, or I want to use natural log because that's on my calculator. So I would say the natural log of a or the natural log of b. So this is just saying base e. And I'm choosing base e or base 10 because those are what are buttons on my calculator. All right, so let's do a couple examples here. Let's expand these out first. So I want to bring the exponent. I'm going to do that first. First, I'm going to, these are multiplied here, so I'm going to add. So this is going to be log base 5 m to the 4th plus log base 5 n squared. Next, I'm going to bring my exponent in front. So this is going to be 4 log base 5 of m plus 2 log base 5 of n. So this is one where I'm multiplying. So let's expand out one where I'm dividing. These are easier if you rewrite them in fractional form. So this is log of base 3. And this is the index. So this is the power. So the index goes in the denominator. So this is m of the 2/3 power and n of the 1/3 power. So first by dividing, when I expand out, then I'm subtracting. So this will be log m of 2/3 minus base 3 log base 3 of n to the 1/3. Now I want to bring the exponent in front. So 2/3 log base 3 of m minus, I wrote 1/2, 1/3 log base 3 of n. Okay, so this is taking from condensed to expanded, so let's go the other way. I'm expanded, so let's condense it. So I'm going to bring the exponent up, and then since I'm adding, I know I'm going to multiply here. So this is going to be log base 2 mn squared. Okay, this is going to be the exponent here and the exponent here. Since I'm subtracting here, I know I'm dividing. So log base 2 of m to the 1/2 and n cubed. So usually we show the m to the 1/2 as the square root. So log base 2 square root of m over n cubed. I would accept either, but with the square root symbol is typically how we show that. I can also do these on the calculator. There are no calculator type questions though on the SAT. And I have this on here twice. I meant to delete this. I'm sorry. Okay, so how do I find these in the calculator? I can find them by picking alpha, window, 5, log base, or I can use the math button, move up twice, and go a to the log of base. So I can find this 2 different ways on the calculator and get to the same thing. So using a common base, evaluate the expression. So either way, I would do one problem trying one way and the other problem the other way, so you know how to use them on your calculator. And when I evaluate this, usually we round 3 decimal places. So this would be approximately 2.262. And then log of base 12 of 51 would be approximately 1.582. So make sure you know how to find it on your calculator.